Hey everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this trigonometric equation problem to solve. We have sine of x plus square root of 2 minus sine squared of x plus sine x times square root of 2 minus sine squared x equal to 3. Okay, the first approach that we're going to be doing is letting the expression with the square root to be equal to a new variable in order to get out with the square root. Okay, so we're going to let the square root of 2 minus sine squared of x to be equal to, let's say, a. Okay, and now what about the sign outside? The sign outside, we can say it's equal to a variable b. Okay, so this expression, which is not the same as this expression, it has a sign, but it's not the same. So we are letting to be a variable a, and we're letting the sign outside to be a variable b. So the second approach that we can do it here is squaring both sides. If we square both sides, we're going to have 2 minus sine squared of x equal to a squared. And if we square here, because if the sine of x is equal to b, we can square. So we're going to have sine squared x equal to b squared. Why we decided to square? Because the first equation we have sine squared, so that we can simplify both of them and we only have a and b. Okay, so if we add those two equations, we're going to simplify these two because they are symmetric. So we're going to have 2 plus 0, which is 2, equal to a squared plus b squared. Okay, so having this expression now, we have one equation, but there is infinite solution for a squared plus b squared. So then what we're going to do is substituting a squared and b squared in the equation given. So we know that this expression is equal to a, and we know that sine x is equal to b. So if we substitute where there is this expression a, we're going to have b there, here's going to be b, plus here's going to be a, plus here's going to be b, times here's going to be a equal to 3. Now we have two equations now, so that means we have now a simultaneous equation whereby we have a squared plus b squared equal to 2, and here we have a plus b plus a times b equal to 3. And we know that a squared plus a squared, it's the same as a plus b all squared minus 2ab equal to 3. And here we can say a plus b plus a times b equal to 3. Okay, here's 2. Okay, perfect now. So we have a plus b, ab. We can still let again that a plus b, it's a new variable, for example m, and a times b, it's another variable n. Okay, so we're going to have a new simultaneous equation with m squared minus 2n equal to 2, and here we're going to have m plus n equal to 3. We're going to have now, in this case, m squared minus 2n equal to 2, and m plus n equal to 3. So if we multiply the second equation by 2, what is going to happen? We're going to multiply and add them. When we multiply with m, it's going to be 2m, so we add, we're going to have m squared plus 2m. When we multiply, it's going to be 2n, they are symmetric, they're going to cancel out. So this is going to be equal to, this is 6 plus 2 is 8. So that means we can now send this 8 here. So we have negative 8. So m squared plus 2m plus 1 minus 9 is equal to 0. 1 minus 9 is still minus 8. So it's going to be m plus 1 squared. For this part, it's perfect square. Negative 1 comes this side as a positive. So m plus 1 is going to be equal to plus or minus square root of 9. Okay, so let's carry on solving. So what we realize in this case is that we're going to have here m, the marker is behaving bad, m is going to be equal to minus 1, it's positive, goes the negative, plus or minus 3. So m is going to be equal, minus 1 plus 3 is 2, or m is going to be equal, minus 1 minus 3 is minus 4. Okay, so we have two values for m. We can just find the value of n. So we have 4 m equal to minus 4, for example, and it's gonna be 3 minus m. So n is gonna be 3 minus minus 4, which is 7. But 4 m equal to 2, then n plus m, which is already 2, is equal to 3. Okay, so n is going to be equal to 1. Okay, we have those two approaches. But we are not given the problem in terms of m. We had first in terms of a and b. So let's try solve and find what's the value of a and b. Since we have a lot of solutions here, we have for m equal to 2, we got n1. For m equal to minus 4, we got n7. So let's work first for m equal to 2 and n equal to 1. So if we work there, then we're going to have, in this particular case, a plus b to be equal to m. So we're using m equal to 2. So a times b is going to be equal to 1. So if we isolate a, then a is equal to 2 minus b. And we substitute in the second equation, we have b times 2 minus b equal to 1. And we have minus b squared plus 2b. This one can come here negative. Multiplying both expressions by minus 1, we have b squared minus 2b plus 1 equal to 0. So it's the same as b minus 1 squared equal to 0, so b is equal to 1. If b is 1, then that means a is 1, because if we substitute there, here, we get 2 minus 1, which is 1. So having b equal to 1 and a equal to 1, we can just replace wherever we want, but here is easier. We can just replace them, whereby we have sine x equal to b, but b is 1. So sine x is equal to sine of pi over 2, which is 90 degrees. Okay, so that implies that x is going to be equal to pi over 2 plus 2kp, or x equal to pi minus pi over 2 plus 2kp. Okay, here will be negative pi, but negative pi, if we substitute in our equation, won't verify. So that means for this problem, the solution is only pi over 2 plus 2kp. Okay, for this first approach. Now we have another approach, which is for m equal to minus 4, and we have that n was equal to 7, which the equation was a plus b equal to, in this case, m. Our m is minus 4, and a times b equal to 7. If we isolate a, then we're going to have a is going to be minus 4 minus b. We substitute in the second equation, we have minus 4 minus b times b equal to 7, minus 4b minus b squared minus 7 equal to 0. Multiplying by negative 1, we have b squared plus 4b plus 7 equal to 0. So if we find the determinant, the delta here, we're going to have 4 squared minus 4, the coefficient here and the constant, this is going to be less than 0, and doesn't exist in real number. So therefore, the only solution is simply x equal to pi over 2 plus 2kp, where k is an integer number. Okay. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.